March 8th through the 12th. This is lesson 25. Alright. We are going to be looking at adding and subtracting rational expressions. That's what the whole entire lesson is about today. We've been looking at rational expressions for a few lessons now, so let's just go ahead and dive into this. It says calculate the following sum, 3/10 plus 6/10. Guys, basically you know that when you are adding fractions, as long as they have a common denominator, my denominator stays the same, and I just add the top, so 6 plus 3 is 9. So I would get 9/10. Very simple, very easy. So let's talk about a rule that would help for adding and subtracting rational numbers. We're just going to generalize a rule. So if I have A, B, and C are integers, and B cannot equal 0, alright, so then I know that A over B plus C over B is equal to A plus C over B. Alright, notice my denominators are the same. They have to be the same when I'm adding or subtracting. Alright, so the same thing, A over B minus C over B would be A minus C over B. Okay? Once again, common denominator has to be there. Alright? But what if they have different denominators? Alright, so let's look at this. What do I have to do? If they have different denominators, let's just kind of look at an example, 2/5 and 1/3. Alright? So let's say I want to add 2/5 plus 1/3. My B's are not the same. So I have to figure that out. When you first learned to add fractions, you looked at them on number lines. You looked at them in tape diagrams. But we have to find a common denominator. Alright? So the easiest thing for you to do, if you cannot figure out the common denominator, multiply the two of the numbers together. 5 times 3 is 15. Then I'm going to ask myself, 5 goes into 15 3 times. 3 times 2 is 6. 3 goes into 15 5 times. 5 times 1 is 5. And now I'm down to common denominators. So 6 plus 5 is 11 over 15. Alright? So let's generalize this into a rule. What if we don't have common denominators? So what if we have A over B plus C over D? Well, then what we do is we multiply B times D, and then we would have to multiply A times D, and we would have to multiply C times B. And this may be where you guys have been taught to do some cross multiplication. Okay? It is the same thing for subtraction. A over B minus C over D. I would multiply BD. And then A would have to be multiplied times D. And C would have to be multiplied times B. Okay? And I could subtract them. I guess I need to go ahead and finish this. AD minus CB over BD. Or this would be plus. And then AD minus CB over BD. Alright? So let's go ahead and look at some, number 2. 3/20 minus 4/15. Alright? Common denominator, like I said. You can multiply the two of them together, or if you can figure out something a little bit simpler, they both actually go into 60. 20 goes into 60 3 times, so 3 times 3 is 9. 15 goes into 60 4 times, so 4 times 4 is 16. So now I'm going to go ahead and figure this out. 9 minus 16 is negative 7 over 60. And I'm finished. Alright. Pi over 4 plus the square root of 2 over 5. Common denominator, I can do 20. Alright, so pi, or 4 goes into 25 times. 5 times pi is 5 pi. Alright, 5 goes into 24 times. 4 times the square root of 2 is 4 square root of 2. Now, here's where I've got to figure out what I got to do. I cannot combine those because one has pi in there, and the other has the square root in it. So I'm just going to combine them like this. 5 pi plus 4 square root of 2 over 20. Alright? A over m plus 2 over, or b over 2m minus c over m. I need to find a common denominator. I have an m, and a 2m. Well, I can use 2m as my denominator. M goes into 2m 2 times. So 2 times a is 2a. This one does not change, so b stays on top. And m goes into 2m 2 times. 2 times c is 2c. Alright? And I can go ahead and combine them. I can't actually combine anything, but I can rewrite it as 2a plus b minus 2c over 2m. And that's your answer. Before we can add rational numbers or rational expressions, we need to convert to equivalent rational expressions with the same denominator. Finding such a denominator involves finding a common multiple of the original denominator. For example, 60 was a common multiple of 20 and 15. There were other common multiples such as 120, 180, 300, but smaller numbers are easier to work with. Alright? To add and subtract rational expressions, we follow the same procedure as when adding and subtracting rational numbers. First, we find a denominator that's the common multiple. Then we rewrite the expressions as equivalent rational expressions. And then we apply the rules for adding and subtracting with the same denominator. Alright, so let's go ahead and dive into this. Exercise number 1. Perform the indicated operation below and simplify. A plus b over 4 plus 2a minus b over 5. Common denominator, I've got 4 and 5. So I'm going to use a common multiple. We'll use 20. Alright, so I know I'm going to have to multiply a plus b by something. 4 times what gives me 20? 4 times 5 gives me 20, so I've got to multiply the top by 5. I know I'm going to have to multiply 2a minus b times something. 5 goes into 24 times, so I'm going to multiply the top by 4. Alright, now I'm going to go ahead and fix this or simplify it. So I get 5a plus 5b over 20 plus 8a minus 4b over 20. And now I can go ahead and combine my like terms. So 5a plus 8a is 13a. 5b minus 4b is positive b. So I get 13a plus b over 20. Look at b. I have 4 over 3x minus 3 over 5x squared. I have to be careful because I've got to make sure I cover every aspect of the denominator. So I'm going to start with my numbers. I have 3 and I have 5. I'm going to use 15. And then I'm going to do the x. So I've got x and x squared. So in order to have a common denominator, I've got to look at something at least x squared or bigger. So we can use x squared. So my common denominator is 15x squared. Alright, so I'm going to come up here and I'm going to put 4 in parentheses. And I'm going to put 3 in parentheses because I know I'm going to have to do some multiplication. So 3 goes into 15 5 times. And x goes into x squared x times. So I know I'm going to have to multiply 4 times 5x. Alright? 5 goes into 15 3 times. And I have x squared here. So x squared goes into x squared only 1 time. So all I'm multiplying is by 3 here. Now I'm going to simplify. So 5x times 4 is 20x over 15x squared. Minus 3 times 3 is 9 over 15x squared. I cannot combine those like terms, so I'm just going to put 20x minus 9 over 15x squared. Alright, and that is my answer. Let's look at C. Alright, in this case, it's going to become just a little bit more difficult because I do have these. I have some polynomials on the bottom, but I'm going to simplify these. We're going to start off by simplifying. So I've got 2x squared plus 2x. I can pull a 2x out of that. I'm left with x plus 1. And then I'm going to come over here, and I'm going to see if I can factor this. So I can factor x squared by x and x. It is a minus minus, so I want to be able to subtract my factors of 4 and get 3. So I'm going to use 4 and 1. It's a negative 3, so my 4 has to be negative, and my 1 has to be positive. Alright? Now I can look at my common denominator. Guys, common denominator is going to look like this. I'm going to combine it all together. But I've got x plus 1 in both of them, so I'm only going to write that one time. So my common denominator is going to be 2x times x plus 1 times x minus 4. Alright? Alright, now I've got to do my multiplication. So 2x times x plus 1 times x minus 4. And I'm going to go ahead and put 3 here because I know I'm going to have to multiply it by something. And I'm going to go ahead and put 5 here because I know I'm going to have to multiply it by something. Alright, so let's look at this. Let's go from my original. I have a 2x and I have an x plus 1. What is the only thing I'm missing? I'm missing the x minus 4. So I've got to multiply it by times x minus 4. Let's go over here. I'm missing the 2x. I have x minus 4 and I have x plus 1, so I only have to multiply it times 2x. Alright, let's go ahead and multiply through. So 3x, or 3 times x is 3x, and 3 times negative 4 is minus 12, over 2x times x plus 1 times x minus 4. And 5 times 2x is 10x, over 2x times x plus 1 times x minus 4. Alright, and now I'm going to combine my like terms. So 3x and 10x is 13x minus 12 over 2x times x plus 1 times x minus 4. And you are finished. Okay? Perform the indicated operations for each problem below. Alright. If you can factor your denominators in any way to make them simpler, do it. If not, it's okay. So I've got 5 over x minus 2, nothing I can do with that. But look at the 4x minus 8. I can pull a 4 out of there, and I get x minus 2. So my common denominator, they both already have x minus 2. So my common denominator is going to be 4 times x minus 2. Alright, I'm going to go ahead and bring my 5 over and bring my 3x over, because I'm going to have to do some multiplication. Alright, let's look at my original fraction and my new fraction. I have x minus 2. The only thing I'm missing is the 4. So I've got to multiply 5 times 4. Look at this fraction versus this fraction. Look, I already have everything, so this one does not change. So let's simplify. 5 times 4 is 20 over 4 times x minus 2 plus 3x times, or over 4 times x minus 2. I cannot combine 20 and 3x, so I'm just going to rewrite it like this. 20 plus 3x is over 4 times x minus 2. And I'm finished. Alright, look at my common denominator here. If you look at this, notice that 3 minus m is equal to m negative times m minus 3. Alright? So my common denominator is going to be m minus 3. Alright? M minus 3 is going to be my common denominator. Alright, so this one does not change. I already have m minus 3 there, so I'm just going to do 7n. Alright, I've got 3 minus n. I need to multiply that times negative 1 to get m minus 3. So negative 1 times 5n is a negative 5n. Alright? So 7n minus 5m is 2m over m minus 3. Alright, let's look at this one. It looks like I'm probably going to do some factoring. So let's see if I can factor. So b squared would be b and b. C squared would be c and c. And they're both going to be negative. Minus b over b minus c. Alright, so I've got b minus c here, and I've got 2 of them here. So my common denominator has to be both of them. So b minus c, b minus c. Alright, so let's look. I have 2 b minus c's here, so this one does not change. So it stays b squared. Let's look at this one. I only have 1, so that means I have to multiply my b times b minus c. Alright? Now I'm going to simplify this, so I have b squared over b minus c times b minus c minus b times b is b squared. B times negative c is negative bc over b minus c times b minus c. So b squared minus b squared is 0. And 0 minus a negative b squared is a positive bc is a positive bc over b minus c times b minus c. Alright? And you can write it this way, or you can say bc over b minus c squared. All right, let's look at number 8. Number 8, I can factor. So I have x over difference of two perfect squares, x plus 1, x minus 1, minus 2x over, let's factor this, I get x and x, I'm going to do 2 and 1, 2 is going to be positive, it's going to be negative. Alright, so what is my common denominator? In this case, they share an x minus 1, so I only have to write that down once. But then I have to write down the x plus 1 and the x plus 2. Alright, so that's my common denominator. Alright, so now let's go ahead and I'm going to put my x here because I know I'm going to have to multiply it by something. And I'm going to put my 2x there because I know I'm going to have to multiply it by something. Alright, let's look at this. Let's compare our first fraction here. I have x minus 1. I have x plus 1. The only thing that's missing is the x plus 2. So I have to multiply it times x plus 2. Alright, let's compare this one. I have x plus 2 and x minus 1. The only thing I'm missing is the x plus 1, so I have to multiply the top by that. And now I can go ahead and simplify. X times x is x squared. X times 2 is 2x. Over x plus 1 times x minus 1 times x plus 2. Minus 2x times x is 2x squared. And 2x times 1 is 2x. Over x plus 1 over x minus 1 over x plus 2. Alright. So now let's go ahead. I've got x squared minus 2x squared, so I have a negative x squared. Alright. And 2x minus 2x gives me 0. So here's my answer. Negative x squared over x plus 1 times x minus 1 times x plus 2. Alright, the next problem is the last problem we're going to do. It is a complex fraction. Let's talk about what a complex fraction is. Complex fractions are fractions within a fraction. Alright, so notice I've got a fraction in the top and I've got a fraction in the bottom. We've got to rewrite this complex fraction as the division of rational numbers. Alright, which means we're going to have to add some parentheses. Alright, so let's rewrite it out. Let's rewrite it like this. We're going to do b squared plus b minus 1 over 2b minus 1 and then minus 1 divided by 4 minus 8 over b plus 1. Alright, so we're going to rewrite it like this. All we did is write it out so it doesn't look so scary. Okay? Now, remember that to divide rational expressions, we multiply by the reciprocal of the quotient. However, we first need to write each rational expression as an equivalent PQ form. Alright, so let's start with this part. So we're going to have to find common denominators. I need a common denominator for this part here. So b squared plus b minus 1 over 2b minus 1 minus 1. Alright, so my common denominator is going to be 2b minus 1. Okay? Now, if I look at this part of my fraction, nothing changes. So I'm just going to bring that b squared plus b minus 1 over. Now let's look at this. How many wholes make a whole when I have 2b minus 1? Well, I'm missing all of the 2b minus 1. So 1 times 2b minus 1 is 2b minus 1. All right? And then I can go ahead and simplify it. So b squared minus 0 is b squared. B minus 2b is minus b. And negative 1 minus a negative 1. So negative 1 plus 1 zeroes out. So this is what I end up with. B squared minus b over 2b plus 1. Alright, now I'm going to come over and I'm going to do the same thing for this one. So 4 minus 8 over b plus 1. So my common denominator is going to be b plus 1. I'm missing all of that here, so I have to multiply it times 4. So I'm just going to rewrite it as 4 times b plus 1. This one I have everything, so it's just going to be minus 8. Alright? So I get 4b plus 4 over b plus 1 minus 8 times b plus 1. I get 4b minus 4 over b plus 1. Alright, now I can simplify that if I want by pulling out a 4. And I can leave it as 4 times b minus 1 over b plus 1. Now we substitute these into our problem. Alright? So let's go ahead and I'm going to come over on the back because I'm going to run out of room here. We're going to substitute this into our original problem. So what did we get for this? We ended up with b squared minus b over 2b minus 1. Divided by, and what did we get for this? 4 over b minus 1, or 4 times b minus 1 over b plus 1. Now, if you remember, in dividing fractions, you keep the first one. So b squared minus b over 2b minus 1. Change that to multiplication and flip the second fraction. And now I can simplify this. Alright? So b squared minus b times b plus 1. Alright? I can multiply straight across. If you remember, I can multiply straight across, or I can look at it like this. Let me show you a different thing. I can take a b out here, and I get b minus 1 over 2b minus 1 times b plus 1 over 4 times b minus 1. Guys, I don't know if you ever learned this, but when I multiply these and I get them over a fraction, it's like the same thing as saying 2 divided by 2. So look, those kind of cancel out because they don't zero out, but they 1 out. They're the same thing as 2 divided by 2 is equal to 1. So this is what I get, b times b plus 1 over 4 times 2b minus 1. And I'm finished. I don't have to go any further with this. It didn't ask me to write it in any special way, so there you go. You've got it. All right? Guys, have a great rest of the week, and hopefully I'll see you guys back next week.